You ever stop and think about what's really going on when you hit play on a movie? It feels like magic, right? But it's not. You're actually tapping into this whole hidden architecture, a system that controls everything from your load times to your data security. So today, we're going to pull back the curtain and dive right into that hidden world.
Okay, so let's get right to it. What is the actual difference between, say, Netflix streaming you a movie and BitTorrent sending you a file? I mean, they both get you what you want, right? Well, the answer, it reveals two totally different ways of thinking about how the internet should work. And honestly, it might just change the way you look at your own connection to everything online. All right, so first things first, we've got to break down the system that, let's be honest, we all use every single day, probably without giving it a second thought. This is the classic client-server model. It's basically the foundation of the modern web as we know it.
Think of it like a giant central library. The server? That's the all-knowing librarian behind the main desk. And all of us, we're the clients, lining up to ask for books. The librarian goes, finds what we need, and hands it over. Simple, right? Super organized. When you're just browsing the web, your browser is the client asking the question. And the website you're on, that's living on a server, the librarian.
But what happens if that one librarian gets totally swamped? Or, just calls in sick for the day? Uh-oh. This right here, this is the Achilles heel of the whole centralized model. It's called a single point of failure.
So let's stick with that library analogy for a second. Imagine a brand new bestseller drops, and everyone rushes the library at the same time. What happens? A massive bottleneck, that's what. Our poor librarian can only handle so many requests at once. And worse, if that librarian just doesn't show up, the whole library shuts down. That's it. Doors are locked, nobody gets any books. That is the fundamental weakness of having everything in one central place.
Okay, so faced with these exact problems, a pretty radical new idea started to bubble up. And this wasn't just about tweaking the old model. It was about throwing it out the window completely. So, welcome to the peer-to-peer revolution.
Now imagine this. Instead of that one central library, what if we connected everyone's personal bookshelves together? That's kind of what a P2P network is. Every single user is both a borrower and a lender. You can grab a book from your neighbor, and hey, they can grab one from you. All of a sudden, the power shifts from that one central server to the edge of the network, which is, well, us, the users.
And this idea isn't exactly new. It's been around for a while. I mean, even the granddaddy of the internet, ARPANET, was basically a peer-to-peer system. But the thing that really blew it up and put P2P on the map, that was a little controversial music sharing service back in 1999 called Napster. Man, Napster showed the entire world just how powerful this model could be, and it totally paved the way for things we know today like BitTorrent and Skype.
But here's the thing. This newfound power was messy. It was chaotic. The first P2P networks were like a gigantic, completely disorganized book swap with no card catalog, no system whatsoever. Just trying to find what you were looking for was a nightmare. So the next big evolution was all about bringing some smarts, some order, to this decentralized chaos.
And what happened is P2P systems kind of split into two main families. On one side, you've got the unstructured networks. Think of these as the Wild West of early file sharing, total free-for-all. But on the other side, you've got structured networks. Now, these are still decentralized, but they have this incredible hidden intelligence that lets them organize themselves.
And this really shows you the difference, right? Trying to find a file in an unstructured network, it's like standing in the middle of a massive crowd and just shouting, "Hey, does anyone have this book?" You literally have to ask everybody. It's called flooding the network, and it's super inefficient. A structured network, though, that's like having a magical shared index that just tells you, "Oh, you want that book? Go talk to Sarah. She's over there." It's night and day.
So what is this magical index? Well, it's called a distributed hash table, or DHT for short. The easiest way to think about a hash table is like a super efficient address book. A DHT takes that big address book, rips it up into a million tiny pieces, and gives one little piece to every single person on the network. And this was the brilliant idea that finally brought order to the P2P chaos.
Yeah, this visual really makes it click, doesn't it? When you're looking for a file, you're not screaming at the whole network anymore. Nope. You just ask any peer near you. That peer checks its little piece of the address book and goes, I don't have it, but I know someone who's closer to the answer, and it just forwards your request along. So smart!
The key word here is efficiency. Your request makes these smart little hops between just a handful of peers. We're talking a tiny fraction of the whole network. Until bam, it lands on the one person who has the file you need. And then that person sends it straight to you. It's the best of both worlds.
totally decentralized, but also incredibly fast and intelligent.
And that efficiency, that's what unlocks the real power of peer-to-peer, the power of the swarm. So what does this actually mean in the real world? Let's take a look at the benefits and, well, the challenges of relying on a system like this.
Okay, the benefits are huge. First off, you get rid of that central server, which means you get rid of that single point of failure. Boom, gone. The network becomes incredibly resilient. In fact, the more people who join, the stronger and faster the whole thing gets. It's also super cheap to maintain, because hey, we, the users, are providing all the infrastructure. And it's naturally tough against the kinds of attacks that would just take down a central server in a heartbeat.
But of course, that power comes with some serious complexity. I mean, how do you trust a file you're getting from some random anonymous peer? And how on earth do you manage a network where thousands of people are constantly popping in and out? These are really big technical challenges that engineers are still trying to perfect. There's no big company in the middle managing trust or making sure everything's secure.
And make no mistake, P2P is not just about sharing files anymore. It's actually all around us. It was the tech that powered the original version of Skype. It is the absolute backbone of cryptocurrencies like Ethereum. It's even at the heart of massive projects like SETI at Home, which uses all of our computers linked together to search for aliens. How cool is that?
Which brings us to the final and maybe the most important piece of this whole puzzle. Because at the end of the day, whether a system is centralized or decentralized, it doesn't matter if you can't rely on it. So the big question is, how do we build trust into these incredibly complex networks?
Engineers break down this idea of trust into two main concepts, dependability and security. And to build any system you can really count on, you have to nail both of these. These are the big goals for any solid network. Doesn't matter if it's centralized or P2P.
So dependability isn't just one thing. It's actually a whole collection of promises. Availability means the service is there when you go to use it. Reliability means it's not going to crash halfway through what you're doing. And integrity means you can trust that the data hasn't been messed with. Now, trying to guarantee all of this in a P2P network where any given peer could be flaky or even malicious, that is a way bigger challenge than doing it in a nice controlled system run by one company.
So it leaves us in this really fascinating cycle when you think about it. The internet started out decentralized. Then, over time, it became super centralized, dominated by a handful of giant companies and their massive servers. And now? Well, now, thanks to things like crypto and the whole Web3 movement, driven by concerns about privacy and censorship, the pendulum is swinging back towards a decentralized world. So the big question is, where are we heading? Is it going to be some kind of hybrid of both worlds? Or are we going to see a full-on return to a web that's powered by us, the peers? Honestly, the answer to that is still being written right now.